Okay, so in this video we're going to cover how to convert back and forth between rectangular and polar equations. So let's say first we're going to just cover how to convert back and forth whenever you see something like r or sine or something like that. So let's say we have a unit circle, and that was a really bad, oh my goodness. So clearly I cannot draw even a quadrant of a circle, but I will try. Okay, this works. And so let's say we have a coordinate on this unit circle, and now we're going to be making a triangle with this coordinate right here. So this is our x distance, this is our y distance, and this is our angle theta. Well, we know that the cosine of theta is, and this is our radius, right, r. It's x over r. So we know that our x is equal to r cosine theta. And so we also know that the sine of our angle is equal to y over r. So you know that y is equal to r sine theta. And so this is the most important thing whenever you're converting between rectangular and polar. And so let me show you a few examples, because basically whenever you're converting from rectangular to polar, wherever you see x, you want to substitute r cosine theta, and the other way around, you want, whenever you see r, you want to substitute oh, and another thing is actually r is equal to this, because Pythagorean theorem is equal to the square root of x squared plus y squared. This is also important. So whenever you are converting between rectangular and polar, polar and rectangular, when you see r, this is what you want to substitute in. So yeah, let's do some examples. So first up, let's say we have the equation x minus 3 squared plus y squared equals 9, okay? So this is a circle, we can graph it out, and it's centered at 3, and it has a radius of 3, so it'll look something, probably more, oh my god, it'll look something like that, except pretend this is exactly there and it's a perfect circle, like pretend that. But that is roughly what it will look like. So as we said before, wherever we see x, we want to substitute in, we want to substitute in r cosine theta. So this becomes, and whenever we see y, we want to substitute r sine theta. So this, I guess, will become r cosine theta minus 3 squared plus r sine theta squared equals 9. And so as you can see here, this looks pretty ugly, but don't worry. So this becomes r cosine theta squared minus 6 r cosine theta plus 9 plus r sine theta squared. So if you notice, we have an r cosine theta squared here and an r sine theta squared here. So we can turn this into r cosine theta squared plus sine theta squared. And we know that, oh, actually this is r squared. So we know that this, oh my goodness, I can't write. We know that this cosine squared plus sine squared is equal to 1. So this just turns into r squared times 1. So r squared minus 6r, oh my goodness, this is so slow, 6r cosine theta plus 9, and we forgot to do the equals 9 here, equals 9. So we get that r squared minus 6r cosine theta, if this will load, sorry, give it a second, theta equals 0 because we just subtracted the 9s. And so that also tells us that r squared is equal to 6r cosine theta, and then we can divide both sides by r because we know r isn't 0, and so this tells us that r is equal to 6 cosine theta, which, as I hope you know, this represents a circle with diameter 6, and that is right of the pole, or right of the origin. So this is exactly what this is, and so that's how we would convert these rectangular coordinates to polar form. Okay, now let's do an example of the other way around. So let's say we have something like r equals 5 over 3 plus 2 sine theta. Well, we know that y equals r sine theta, and so we know that sine theta is equal to y over r, which is important. So we can make this into r equals 5 over 3 plus 2y over r. And then what we can do is we can multiply both sides of this equation by I'm thinking let's multiply both the top, the numerator, and the denominator of this equation by r. So we can multiply this by r over r, and this gives us r equals 5r over 3r plus 2y. And so we can multiply the denominator up to get 3r squared plus 2yr equals 5r. And so then we can divide everything here by r. So we get that 3r plus 2y equals 5. So this tells us 3r equals 5 minus 2y. Okay, but we still have to get this into terms of just x squared, just x and y. And so we know that r is the square root of x squared plus y squared. So we can say that this means that 3 times the x squared of the square root of x squared plus y squared equals 5 minus 2y. And to get rid of the square root, of course, we're going to have to square both sides. And this gives us 9 times x squared plus y squared equals 5 minus 2y squared, which is 25 minus 20y plus 4y squared. Wow, okay, so this becomes 9x squared plus 9y squared. If this will load, give it a second, give it 2 seconds. Okay, equals 25 minus 20y plus 4y squared. And so when we add like terms and get everything to one side, this becomes this becomes 9x squared plus 9y squared plus 20y. Oh, actually, the 9y squared, we have to subtract the 4y squared. So this becomes plus 5y squared because of this, and then plus 20y. And this actually doesn't look too bad. Equals 25, because this literally I came up with right now. They're just random numbers. So this will become 9x squared plus 5y plus y squared. This is y squared plus 4y, right? But when we convert this to an ellipse, we need to complete the square. So this tells us that we have to do, this is just, we're just normally converting this to an ellipse. Y plus 2 squared, which I probably don't have to show you, but I will do it anyways, plus 20, because this is 4 squared plus 20. And so we get, no way, it turned out into an actual good ellipse. That's crazy. So this equals 45. And so this we get x squared, so we divide both sides by 45, divided by 45, divided by 45. So this becomes x squared over 5 plus y plus 2 squared over 9 equals 1. And that is how we determine that the equation that we just made was an ellipse, and a rather nice one as well. But yeah, that's how you convert between rectangular and polar. It's not hard, it's just there's a few things you should know, and then after that it's just substitution and algebra.